Next comes the Spring Boot. While discussing more about Spring Boot, we can have a look on what is before Spring Boot. Mainly Java uses a framework called Spring to develop Java-based frame and web application, Java application. The Spring framework provides support for application development, dependency injection, aspect-oriented programming, transaction management, data accessing, and several others. Dependency injection in Spring Boot in Spring is the case where the objects are provided with their dependencies rather than creating them internally. If we are saying that we need a web service, then the basic steps for all the web service will be included in that project. So that's the dependency injection. Aspect-oriented programming means it allows the developers to separate cross-cutting concerns like as external activity like logging, security, database operation from the core business logic. So the programmer can focus on the business logic and can be abstracted out from the external world. It also enables the modularization of concerns, leading to cleaner and more maintainable code. Next comes the Spring IOC container. So IOC stands for inversion of control container that manages the lifecycle of Java objects like beans. Beans is a Java class. This is a public class which contains private instance members, public constructors, public constructors, and public getters and setters for accessing it, assigning values respectively. That is a bean. For controlling the life cycle of bean, how will bean created, what is the intermediate process between the birth and death of a Spring bean is handled by the Spring IOC container. It is responsible for instantiating, configuring, and assembling the beans based on the metadata provided. Next comes the data access. Data access in the sense is the method is the techniques that used to handle the database in our application. To handle or communicate with the database, we use JDBC, JPA, Hibernate, and Spring Data-like stuffs. Here, JDBC is a low-level API, while JPA is a high-level API. Hibernate is a ORM framework that used in the database accessing and all, and the Spring Data is a component of a direct component of a Spring framework that enables that employs working with the database. Okay, ORM in the sense object relational mapping. ORM is a property used in recent web service, new evolving web service that enables us, prevent us from writing raw database queries to access the database objects and all to perform database operation. Instead of that, we can use the direct language in which we are developing the application to access the database. It is the ORM framework. One of the examples of ORM framework for the Java Spring is Hibernate. It simplifies the database operation and provides abstraction layers, as I mentioned. Next comes the transaction management. Transaction in the sense we can take an example of payment. Either payment must be done or it must be rolled back. Either the money must be transferred to another account or must not transfer and must be in the client's account itself. No intermediary state must not be present. Like the database operation also must not have any intermediate state. If successful, data must be created in the object or the corresponding operation must be performed. If failure, no access must be done in the database. That is, no temporary or some partial values must be added to the database. It is a wrong or it is not a fair method. That is meant by the transaction management. Next comes the security. Security is the main and crucial component in all fields of life. Security in the sense for Spring is a powerful authentication and authorization framework for securing Java-based application. It also provides authentication, giving the specific rights to specific users. Access control and session management. Session in the sense the user tracking the user when once logged in until the user sign out from that application. Next comes integration. Integration in the sense used to integrate separate components like third-party plugins like message, service, payment gateway, like that stuffs. For integrating, integration is also can be done with the Spring framework. Next comes the testing. Testing in the sense there is the need of unit testing, integration testing, user acceptance testing, QA testing, and several others. For each of them, Spring provides different framework. For unit test, the framework are JUnit and Mockito. For integration test, several others and all is there. Next comes the advanced form of Spring, that is Spring MVC. Spring MVC stands for Model View Controller. That is mainly this Spring framework is again divided into three components, segregated into three components for easy understanding, for readability and all. M4 stands for model. Model means the class or file used to access the database object. View is the UI part, or front end part. Controller is the control main business logic where the computation is performed. And a simple word we can use Spring MVC is a Spring module for using the building web application and REST API using the Java language. Earlier, instead of Spring MVC, struts was used, but it was very much complex when compared to Spring MVC. This make it easier. The Spring MVC makes the creation of a web application easier task by using annotations like controller, host controller, request mapping and all, which we can be discussed in a separate part mentioned as annotation in this lecture itself. So we can cover at that time. So I will mention that time. Next we can discuss about the issues when using Spring and Spring MVC. Spring and Spring MVC, as we said, we use dependency management, which is automatic internal addition of different components to the application, web application configuration, Spring configuration, and non-functional requirement gathering and all, managing the Spring basic Spring components like beans. But this all has to be done manually in the Spring and Spring MVC's case. Okay. If we need to add dependency management, we need to add the separate dependencies manually in the pom.xml file. Okay. For creating a REST API web application using REST API, we need to manually add the Spring framework, Spring MVC framework, JSON binding framework if you are using the JSON and all. So if you need to unit test components, we need to manually include the Spring test, Mockito, and unit test separately. When we are configuring a web application, dispatcher serverless has to be done. It has to be configured separately and manually. Next comes the Spring configuration. Spring configuration means the base, as we know, model, view, and controller. For these three, we need to separately add separate components manually, like component scan for controllers, and I think, and view resolver for viewing steps, data source components for access, model case for models, that is for handling the database request and responses. Next comes the non-functional requirement that has to be added in addition to the business logic. That is logging. Logging means keeping track of our applications working. Error handling means the preventing a system from a crash. Monitoring, the overall monitoring of a system that run. That all has to be separately managed using the separate framework by the user. For one issue is that this need to be repeated for every new project while we are creating. This will take a few days to set up. So that's the issue. To overcome that issue, 2016 the Spring Boot framework has been evolved. It is not a competitor or separate item for that to replace the Spring and Spring MVC. It is a stuff that make use of Spring and Spring MVC and build stuffs using the Spring and Spring MVC automatically. We can say Spring Boot is a Spring project which builds production ready apps very quickly. Okay. To overcome the issues that we mentioned earlier, we can use the Spring Boot. While considering or explaining Spring Boot, we can separate it to different parts, that is starter projects, auto configuration, and non-functional requirements. Starter projects, in the sense when we say that we need a web application, all the necessary dependencies, basic necessary and fundamental necessary dependencies must be added automatically. That is gathered under the starter project concept. It simplifies the process of setting up a new project by providing a pre-defined structure or framework and configuration. Example, if we say that we need to develop a web application using Spring, it will automatically include starter test component, starter web component, starter security component, because all the security testing and all is needed by a software project. Next comes the auto configuration. That is, the downloaded items need to be configured or added to the path to become achievable or runnable in our context. So to eliminate the manual configuration of setting up the Spring MVC and other defined frameworks, the Spring Boot provides a default configuration whatever in the class path and automatically. If you do not provide any basic stuff or manual path or manually, by taking a default path, it will download it automatically for the user. Next comes the third-party application and non-functional equipment like logging, error handling, on profile setting, server setting up and all will be comes under the non-functional equipment. It is also basic non-functional equipments will also be automatically added to our project using Spring Boot. While diving deep into the Spring Boot, we can go through the architecture of the Spring Boot. To understand the architecture, we need to know the different layers present in the Spring Boot. Mainly 4 layers is present: presentation layer, business layer, persistent layer, and database layer. As you can see in the image, presentation layer is the UI part, where the authentication of user and the conversion of Java object to JSON and JSON to Java object done to make it machine and user friendly respectively. Next comes the business layer, where the business logic, where the purpose of the software development is done, and validation of the steps and authorization of the user to provide the current access to the business logic. Next comes the persistent layer. Persistent layer is the layer where the storage is done locally for the storage for business logic or software product is done out from the database, actual database. Here we use the ORM frameworks, JPA, JDBC, and like that stuff. Not only that, repository concept is also used here to store or to abstract the actual communication with the database logic, which can be harmful to our application. So that is done in the persistence layer. The database layer is the actual database access and the basic main CRUD operation, creation, deletion, updation, and all using the HTTP request and response is done to the database and from the database. As you can see the black arrows in the middle of each layers, you can see each layer only communicate with the other layers present as the immediate predecessor or immediate successor. No communication to other layers is present in this Spring Boot architecture. So we can go through dive deep into the architecture. Initially, client makes an HTTP request, and this request is initially going to the controller. The controller decides whether it is a database operation or other only processing operation. If it has a database operation, then only it will give it to the model and database steps. Otherwise, it will be handled in the service layer. The request will be handled in the service layer. In a request, the controller will pass into the service layer, and the service layer defines whether to pass to the model or need to be handled within this service layer itself. In the service layer, all the business logic is performed. It performs the logic on the data and is mapped to GPU with model class. After that, the user requested data is shown to the client as a JSP page, the server page. That's all about the architecture. Let's have a look. You can see from the model class to the database, the JPA, Spring Data, Hibernate, JDBC, and all will be come into action. Next comes the dependency management. We have talked about dependency injection in the previous section. And we can discuss about the dependency management, how the different dependency has to be managed. Dependencies are the small steps that our project needs to function properly, which is not provided by the standard libraries, which is each user uses specifically in their software project as the client requirement. Dependency management includes the handling of these external libraries framework modules that our project relies on. Handling them properly will be awesome and more readable and maintainable. The main advantage of the dependency management is shown here: reusability, functionality, version control, security, and build and automation. Reusable in the sense, as the name suggests, we can reuse that component or document that component. We can be reused in the several application in the future when the different clients approach the same request. Once aligned properly, it can be reused by any of the developer, which provides more readability. Functionality is the optimal performance, maximizing the performance and reducing the computation time and all. For the external components, if the standard library is not available, helps us to inbuild third-party complex application more easily to our project. Version control, as the auto configuration is all defined in the Spring Boot, it for the most case it will handle the prevent the version conflict and all, and depend in the pom.xml file by the Spring Boot itself. But in the sense, for a second security measure from the user side, you can also externally track and control the version of external libraries, which reduces the issues and bugs that can unpredictable or common issues and bugs related to the dependency conflict and all can be controlled while the effective dependency using the effective dependency management. Next comes the security. Security in the sense, proper authentication, authorization of this dependency will mitigate the security vulnerabilities, and this dependency management can Spring Boot can internally check for the vulnerability in the libraries and provide guidance to how to solve them. Next comes the build automation of this dependency management. That in the sense, same as auto configuration, streamlines the build process and make it easier to manage the complex dependency graphs and steps. This way the dependency is managed in the Spring Boot. In the case of Spring Boot, dependency management is done using the Spring Boot starters that we have earlier mentioned, like Spring Boot Starter Web, Spring Boot Starter Test, Spring Boot Starter Security. Like that steps in the Spring Boot handles the dependency management in Spring Boot. It is designed to simplify the setup of common tasks and integration. There are also starters for data access, security, messaging, testing, and all. Next come the starter pumps. When we download a Spring Boot application, initialize a Spring Boot application, it will generate a pom.xml file that including the necessary dependency. It automatically pulls in all required dependencies, including the transitive dependencies, to support the functionality provided by the starter. What all are included in the starter will be included in the pom.xml for preventing the errors and all while building the application. Transitive dependencies are the dependencies required by the main dependencies. The main dependencies will be the crucial one or most first class dependencies, and the transitive dependency is the second class or second standard dependencies needed by these main dependencies to work with. So that will also be managed by this dependency management. Next comes the version management, as we have mentioned, handling the different versions of the error dependency to solve the merging version conflict and all. Next comes the customization. Customization means as it provides a default dependency which eliminates the conflicts. If we need to take advantage of the new version of the particular dependency, we can use it. We can use the specific version, but we have to manually take care about the to prevent the version conflict in our application. That is meant by the property of customization. Next means the Maven on gradle integration. Most of the Maven is used, which is easy. When we add more dependency, we have to mention it in the pom.xml file if we are using Maven, or if you are using Gradle, build on the same has to be uploaded in the build.gradle file also. So that is dependency management. That is how the dependency is managed in the Spring Boot. Next comes the annotation. Annotation are the method. Annotation is the method that we are using to achieve these all concepts in our Spring Boot application, like dependency management, usage of steps and all is done using this annotation properties. For each component, for each property, we are using annotation. So we can go to there are built-in annotations which has a definition in the backend. So we only need to use that annotation so that in front of a class or method. So it will return result of the class or method will be modified by this annotation accordingly. Some of the different areas where annotation being used is the component scanning, the dependency injection, the creating RESTful web service, security cases, data access cases, testing cases, auto configuration cases, normal configuration cases. In all areas we use the annotations. We are going through some of the example of each component. The component scanning annotation, most commonly used annotation is the component scan annotation, which is used to automatically detect and register the beans in our application. In the dependency injection area, we use auto-wired annotation, qualifier annotation, value annotation. Auto-wired annotation is used in front of a bean to add that bean to a variable, method, or a constructor. Qualifier annotation is the used when there is a collection of beans, multiple beans are available, and is used to specify which bean from that collection has to be used currently. For that, the qualifier annotation is used. Value annotation is used to add the external files like our system's path, environment files, and variable global parameters needed to be added to our Spring Manager commands like our classes, fields, and constructor arguments, and we are using value annotation. Next comes the RESTful web service. Next comes web service, RESTful web services. RESTful web service are the web service of the era, this era. The most frequently and widely mainly used RESTful web service annotation is REST controller and REST request mapping. REST controller is a combination of controller plus response body. It is used to create basic web service in Spring Boot. The controller annotation specifically make a class as a controller component, allowing it to handle web requests like get, post, requests. Response body annotation is that which handles the responses of the service provider classes in the more serialized way. It will convert the methods in the class, values of the methods in the class into the HTTP response body structure rather than being resolved to a view. Next annotation is request mapping. Request mapping allows us to define the behavior of web application endpoints. Like if we are requesting, then we are using, and we will use get mapping. If we use at request mapping, it is default. In the default case, it takes it assumes Spring Boot assumes it as a get request. If we need to use post put, or if you want that approaches, we have to specifically mention it in the parenthesis as arguments. There is a two argument taken by this request mapping annotation. One is value, another is method. We have to more specifically provide which HTTP method is associated with that. We can provide it in that arguments. Instead of using at request mapping, we can separately focusedly use at get mapping, at post mapping, at put mapping, at delete mapping directly to have the corresponding HTTP request that we can read out from this block. Next comes the data access. That is the working with databases. We use the different type of annotations. Some of them are at entity, ID, and repository. Entity is an annotation that we provide with a class which is used to tell the Spring Boot that the instance of that class should be mapped to corresponding tables in the relation database. If you annotate a class with at entity, their members, the instance members will be each instance of that class. Value of each set of instance members of that class will be stored as a row in the tables of the database, corresponding database. If you mark an instance member with at ID annotation, it marks that ID as a primary key of the corresponding database table. Next comes the at repository annotation. At repository annotation is to maintain the cleaner code organization and enables the automatic exception translation database interaction. Exception translation database interaction. Database interaction means the basic database operation like storage, retrieval, insertion behavior done in the databases. It also includes the abstraction of data access logic from the business logic, so that it won't get mixed up. It will keep that separate and maintain the readability. Next comes exception translation. That is, as we know, the Spring Boot has a error MVC auto configuration file or class to handle the errors in a beautiful manner, but the database doesn't have a user-friendly manner. So the databases used in connection with our Spring Boot application. For that, all databases, the Spring Boot manually can be configured to provide a beautiful error message for the error generated by the database, which is used by the Spring Boot. So when the error generated by the database that is being used by the Spring Boot, the error must be understood by the user. To understand for the user more user friendly, the exception can be translated. The machine code of the error or assembly code of that error can be identified by the Spring Boot specific packages and can be used to user identifier English level, like high level language translator, and can showcase the message to the error message to the user, so that user could understand the error message easily and they can fix it more fast and it increase the productivity of the system for the developers. Next comes the transaction. Transaction in the sense ensure that the entire method is executed within a single database transaction. No intermediate state is present. If the method completes successfully, the transaction is committed. If the exception occurs in the method execution, transaction is rolled back to the previous state. So for that purposes and all, we use the annotation in front of the class method. Next comes the query annotation. Query annotation provides flexibility in defining custom queries. That is for Spring Data repository is if the user or the developer is not happy or the with the standard queries, or if the standard queries is not up to the expectation of the user. We have to we can customize the queries according to the specific principle and defined by the Spring Boot application documentation. Next comes the security feature, web security features. The security for web publication. It includes authentication, authorization, validation, CSRF protection, session management, cookie management, and all. For authorization, we use mainly three annotations: secured, pre-authorized, and post-authorized. Secured in the sense it provides certain controlled roles to the users logging in. For that purpose, secured annotation is used. Pre-authorized, as the name suggests, it performs specific conditions. If the specified preconditions are met, then only the user or client will be entered into a particular method, allowed to execute a particular method or get into a particular class. Post-authorized in the sense that if it will execute a method first, and based on the return value of that method, the authorization is done, and the client will or user will be allowed to further usage of the module. Next comes authentication part. Authentication part uses at authentication principal annotation, which is used to inject the currently authenticated user into the method parameters. Next comes the testing scenario. Testing scenario, we know there is the testing starts from unit testing, integration testing, up to user acceptance testing. Different testing is is there. For each and every one, there is separate annotation in the Spring Boot. For integration test, at Spring Boot test is used. For integration, for the same integration test, with mocking out the components of actual one instead of using the actual, instead of employing the actual database components and all more expensive components, we can mock components and run the testing. For that purpose, the Spring Boot provides at mock bean annotation. Next comes web MVC test, which is used to control the MVC which is used to test the MVC controllers in isolation by mocking and without indulging all the application context for the test case, which can be more expensive. So that expensiveness can be reduced using that web MVC test annotation to control the entire MVC controllers. Next comes the configuration part. Configuration part uses two annotation: configuration and enable web security integration. These two go hand in hand because it is used to provide an alternate XML based configuration to create a custom security configuration for your application. The enable web security annotation is used to enable Spring Security's web security feature in our application. The Spring's default security cases work environment or workflow for that essence of that Spring security can be enabled in our application using at enable web security annotation. Next comes the actuator endpoint. Actuator endpoint is used to configure and expose Spring Boot actuator endpoints. Provides monitoring for our application. For that purpose, we use at enable and actuator annotation and endpoint annotation. Next comes the event handling session. Event handling in the sense to keep track of our application's movement and change the UI or other components accordingly. We need event listeners, annotation components that handles the events. For that, at event listener annotation is provided for the application, for our Spring application. Next comes auto configuration. To enable the auto configuration in our Spring Boot application, we can use annotation provided auto configuration. The main one is that at enable auto configuration one, which can be enable or disable the working of auto configuration. If it is enabled, auto configuration will be automatic enable, and auto configuration of components dependencies specified in the pom.xml file will be added to our application. Next comes the non-functional requirement, that is logging. Logging can also be achieved in our application using annotation like SL for Java, log for Java 2, or at logback at condition on property, like that annotations. You can monitor and keep track of our device working, and business busy area for busy API, busy time schedule, like that. Various feature parameters can be handled through this annotation for login purpose.